Hello BYW students, it's Mr. O'Sullivan. Today we're going to be looking at lesson 8-3, simplifying radicals. Today's learning target is I can simplify a radical by using prime factorization. Today we're going to learn how to rewrite expressions containing radicals. So you're probably wondering, what the heck is a radical? Whenever we say the word radical, we're actually talking about this symbol, which you've seen on your calculator. This process will require us to use prime factorization and a trick called double on the inside, single on the outside. As you move along in your math courses, especially here at BYW, radicals will be playing a major role, especially in geometry. So the steps for simplifying radicals are pretty straightforward. We're going to do an example together, and then you're going to try some. Well, we're going to do the next few together as well. You're going to try some parts by yourself. This example says rewrite radical 75 in simplest radical form. Step 1 says rewrite the prime factorization of the term inside the radical. We did prime factorization a few months ago when we did factoring and we did GCF leftover. So we're going to need to do the prime factorization. So if I look, the number under my radical is a 75. So what I'm going to do is I'm going to find the prime factorization of 75. So I have to ask myself, what are two numbers that multiply to 75? You can use any combination as long as they are whole numbers. The one I'm thinking of right now is 3 and 25. So I'm going to break it apart into 3 and 25. Here's the issue. I can't break apart a 3 anymore, so I'm going to highlight it. And now I'm going to try to break apart a 25. I can break apart a 25. What two numbers multiply to 25? 5 and 5. And if you look, I can't break apart a 5 and a 5. Now, step 2 says rewrite that prime factorization under a radical. So I'm going to rewrite that prime factorization under a radical. So I have 3 times 5 times 5. And now step 3 says highlight your doubles and make them single on the outside. So when I mean doubles is, do I have a pair of something? If you look, I've got 1 3, so there is no such thing as a double 3. If you look, I've got 2 5s. That's what I mean by double. So what we're going to do is we're going to literally circle them or square them and make them single on the outside. So we're just left with a 5. But the issue is whenever I take something away from the inside, it's gone. It's no longer on the inside of my radical. It's just on the outside. So now I'm just left with a 5 radical 3. And that's my final answer. So I can say radical 75 simplifies to 5 radical 3. And that's it. Let's try a few more. Number 1, we want to simplify the square root of 80. So we want to simplify the square root of 80. So we rewrite the prime factorization of 80. So two numbers that multiply to 80 are 8 and 10. Again, you can use any combo as long as they work. What multiplies to 8? 2 and 4. What multiplies to 4? 2 and 2. Can't break apart those 2's. Now I have to ask myself, what breaks apart a 10? 2 and 5. Don't say 5 and 5, because 5 and 5 is 25. Now, all these numbers, I rewrite under a radical, just like this. So I have 1, 2, 3, 4 2's. 1, 2, 3, 4. And then I have a 5. I need to ask myself if I have any doubles. And if I look, I do have some doubles. I've got a double 2. So that becomes single on the outside. I've got another double 2. And that becomes a single on the outside. And then I'm just left with a 5 on the inside of my radical. So what's 2 times 2? It's 4. So I'm left with 4 radical 5 as my final answer. Try to do the next one all by yourself. Okay, so here's how I would approach. I would rewrite my 50, break it apart. I can break it apart into 5 and 10, and then I can break apart a 10 into 2 and 5. Highlight those primes, and if we look, I'm now going to draw a radical and put 2 5s and a 2 in it. Do I have any doubles? Yes, I do. I've got a double 5, so that becomes a single on the outside. So my final answer is 5 radical 2. And that's it. Let's do number 3 together. Number 3 is a little different. So I go to the outside and I rewrite the prime factorization of 36 because I want to find the square root of 36. I break it apart and I have 6 and 6. I can break apart a 6 to be 2 and 3. Highlight those numbers because those are primes. And now I'm going to write them under a radical. And if you look, I've got doubles. I got a double 2, becomes a single on the outside. I got a double 3, becomes a single on the outside. If you look, I have nothing on the inside of my radical, so there's nothing left over. So I will not even be writing a radical. What's 2 times 3? 6. 6 is my final answer. So I can say that the square root of 36 is 6. So what we would say is that 36 is a perfect square. And the reason why is because 6 times 6 is 36. So if I wanted to, I could do the square root of 100 is just 10, because 10 times 10 is 100. What would the square root of 49 be? Very good, it would be 7. Okay, number 4, radical 150. What we're going to do is we're going to break apart this radical. So we have 150. What are 2 numbers that multiply to 150? We have 15 and 10. What multiplies to 15? 3 and 5. What multiplies to 10? 2 and 5. We now highlight our primes. And if we look, we have 1, 2, 1, 3, and 2 5s. So now we're going to put all of those numbers under a radical. So I have 1, 2, 1, 3, and 2 5s. Now, do you have any doubles? Very good, I do have a double. I have a double 5. So I'm going to make that a single on the outside. So now I have to ask myself, what's 2 times 3? 6. So my final answer is 5, radical 6. And that's it. If you have any questions, email myself or Miss Townsend. Have a great day, kids.